Let's walk you through this. What is the molar mass of a gas according to the following experimental data? So this is a classic rearranging and knowing your units type of question. The equation is given here as PV equals nRT, which is pressure times volume equals moles times the gas constant, which is given above as well, and the temperature. Now, we're trying to find the molar mass of a gas, so we can use the equation moles is equal to mass over the molar mass, otherwise the relative formula mass, but because there's only one element in this case, so it's just the molar mass. And we can substitute that into the equation of PV equals nRT. Let me just write up the slightly longer way, but as you do more of these questions, you'll probably be able to just write it like this. Now, as for the units, so for the mass, it is measured in grams, and you might be able to remember this because when we calculate moles, the mass is often left in grams, and that is the same case here, multiplied by the ideal gas constant, which is just as it is given in this case, and multiplied by the temperature in Kelvin. So that would be this, divided by the pressure, which we always measure in just pascals, so you have to convert kilopascals to pascals, times 1,000 to that. And then we multiply that by the volume, which is measured in meters cubed. So if we were to convert 1 meter cubed, that would be equal to that centimeter cubed. So for here, we have to do it the opposite way because we're converting from cm cubed to meters cubed. So that is times 10 to the minus 6. And if you know your standard forms well enough, then you can simplify all of that to 40 times 8.31 times 290 over 98. And for the 1000 and the 10 to the minus 6, that gives us 10 to the minus 3 overall. And if you apply that to just 220, you get 0.22. which means that A is the final answer.